Thank you for this opportunity to testify about the potential role of agriculture and forestry in achieving a low-carbon economy. My comments today are focused on the basic requirements for carbon offsets under an emissions trading program and how agriculture and forestry projects that reduce or sequester greenhouse gas emissions may fare against those requirements. My own study of the issues suggests that agriculture and forestry have an important role to play in lowering the costs of mitigating climate change. At the same time, many types of agriculture and forestry projects may have a harder time meeting the basic criteria for carbon offsets than projects in other sectors. It may be more effective to support these kinds of projects through methods other than a carbon offset program. To understand the issues involved, it is important to clearly define the function of a carbon offset in an emissions trading system. Fundamentally, a carbon offset is a reduction in greenhouse gas emissions that is achieved to compensate for or offset an increase in emissions at another source. To serve this function, carbon offsets need to meet 5 basic criteria. First, carbon offsets must be real. They must reflect a complete accounting of a project's effects on emissions. Any unintended increases in emissions resulting from a project or leakage must be fully accounted for. Second, carbon offsets must be additional. This means they must involve reductions that would not have happened in the absence of a carbon offset program. Third, carbon offsets must be permanent. Offsets that are prone to reversal through fire, harvesting, or other disturbances must have measures in place to compensate for when this occurs. Finally, carbon offsets must be verifiable and they must be enforceable. The biggest challenge for any carbon offset program is finding practical methods to ensure that offsets are real, additional, verifiable, permanent, and enforceable. Fortunately, a lot of work has been done to develop methods for doing so under a variety of programs, both international and domestic, some of them already mentioned here today. The standards developed under these programs would have to be carefully evaluated to determine their compatibility with a federal regulatory offset program. But there is a large body of work to build off of. The larger challenge is deciding which types of projects to include in a carbon offset program. Generally speaking, emission reductions with the lowest uncertainty about their quantification and additionality make the best offsets. Projects that capture and destroy landfill methane, for example, are highly credible because their effects can be directly measured and there is little uncertainty about their additionality. Projects that sequester carbon, on the other hand, including reforestation, forest management, agricultural land management, and avoided deforestation projects, can be more challenging. This is because compared to other types of projects, their effects can be more difficult to measure, their reference cases can be more difficult to establish, they are more prone to leakage, and their emission reductions are subject to reversal. In most cases, it is possible to compensate for these risks and uncertainties, but reducing uncertainty means increasing costs. It may be that these added costs can be borne by a carbon offset market, but it is also worth considering whether the climate benefits of these projects could be achieved in ways that avoid all the costs necessary to certify them as carbon offsets. If such costs could be avoided, then more reductions could be achieved for the same expenditure of resources. One way to do this would be to encourage projects with high quantification uncertainties through a separate program of direct payments or other kinds of incentives. Unlike offsets, reductions achieved through direct payments, for example, would not have to compensate for increased emissions at other sources and therefore would not have to be subject to the same levels of scrutiny in terms of measurement, additionality, leakage, and reversibility. Further study is needed to determine which types of projects might best be encouraged through an offset program and which might be better achieved through other methods. In the meantime, it makes sense to design policies that keep both options open for a variety of emission reduction projects. Thank you very much, and I'm happy to answer any questions.